Okay, today we're going to talk about writing equilibrium expressions. Here are a few basic definitions you need to know before we continue. Chemical equation is a symbolic representation of a chemical equation where the reactants are on the left-hand side and the products are on the right-hand side. Chemical equilibrium is a mixture of reactants and products whose concentrations no longer change with time. The forward and reverse reactions occur at the same rate. Equilibrium expressions, or equations, are indicated by a double arrow, showing forward and backwards reaction. The equilibrium constant is the ratio of concentrations when equilibrium is reached in a reversible reaction. The equilibrium constant is indicated by K. It can be either KEQ, KC, KP, KA, KB, or KSP. All of these mean equilibrium constant. To solve for the equilibrium constant, you set K equal to the concentration of products over the concentration of reactants. So, in a given equation of little a, big A, plus little b, big B, is in equilibrium with little c, big C, plus little d, big D. The little letters, are the coefficients. So, you will have the concentration of big D and big C over the concentrations of big B and big A. But, because these have coefficients, the law of mass action states that you must raise the concentrations to the whole number value of the coefficient that is expressed in the balanced chemical equation. The square brackets indicate concentration. So in a given equation, when it asks you to solve for the K value, it will give you values in either molarity or atmospheres. If it's given in molarity, this indicates concentration. So when you set up your equilibrium expression, you need to have square brackets around your products and reactants. Little p indicates partial pressure. So if you're given something in atmospheres, you know that to set up your equilibrium expression, you need to have little p in front of your products and reactants. An example is in this arbitrary equation, x in a gaseous form is in equilibrium with 2 of y in a gaseous form. So you would have p of y raised to the second power over p of x. Solids and liquids do not appear in equilibrium expressions because they have an assumed value of 1. Let's do some practice problems. In this equation, you have gaseous N2 plus 3 of gaseous H2 in equilibrium with 2 NH3 in gaseous form. So, you do products over reactants. So you have NH3 raised to the second power because its coefficient is 2. Then, you put it over the reactants. So you have it over the concentration of N2 times the concentration of H2 raised to the third power because its coefficient is 3. Or, if you were given values in pressures, then you would have P of NH3 raised to the second over P of N2 times P of H2 raised to the third power. These both mean the same thing, but they differ in notation because the values given to solve for K would be given in either concentration or partial pressure. In this one, you have solid lead chloride is in equilibrium with aqueous lead ions and aqueous chloride ions. In this one, you have KSP is equal to the concentration of lead ions times the concentration of chloride ions raised to the second power because the coefficient is 2. Lead chloride in solid form does not appear in the equilibrium expression because it's a solid and is assumed to be 1. So if you had this over 1, it would equal the exact same thing. In this equation, we have H2O in liquid form plus CO3 minus 2 in aqueous form is in equilibrium with OH minus in aqueous form plus HCO3 minus in aqueous form. This one, you again do products over reactants, so you have HCO3 minus, that ion, right there in concentration, times the concentration of OH minus over the concentration of CO3 minus 2. Water, H2O, is in liquid form, so it again does not appear in the equilibrium expression because it is assumed to be 1.